So I'm Dr. Paul L. I work at the Queens University of Belfast in the UK. I run a centre called the Centre for Data, Digitisation and Analysis. And we're one of the oldest digital humanities centres in the UK and probably the world actually. We were founded in 1999. I'm the founding director of the unit, and our main aim is to use computing, ICT, to help us understand mostly the past, historical data from the past, to address new research debates using electronic data, to use new methodologies, to understand processes that have happened in the past. The Digitising Scotland project is all about taking vital registration data. And vital registration data are essentially births, deaths and marriages. So one person, when they're born, they'll have a birth certificate which is recorded by the Census Office in Edinburgh in Scotland. If they get married, another certificate will be generated to say who they've got married to, and when they die, there'll be a death certificate. All those three vital events are registered in Scotland. And this process began in the 1850s for everyone in Scotland. So there's a lot of data there, about 22 million data records. These are handwritten records, handwritten on a pro forma, on a printed form, and they contain a vast amount of useful information about people's lives. You know, when they were born, where they were born, the family that they were born to, the parents, when they got married, who they were married to, the occupations of the people who got married, and when they died, their age at death, what the disease that might have killed them, that sort of thing. The data haven't been much used in the past, simply because there's so much of it. 22 million handwritten records, they're difficult to read, and any large-scale study really can't use them in their current form. They're available both on microfilm and in handwritten books, but trying to do any large-scale analysis of that data is very difficult indeed. So to date, those sorts of vital registration records have been used by family historians to look back at their own family. What we're interested in doing is looking at a larger scale across the whole population of Scotland to see how those patterns changed over time. For instance, what diseases were killing people in the 19th century? How did that change going into the 20th century? How did the mean age of death, the average age of death, change over time? What age did people get married? Were they marrying outside their social class, perhaps? A whole range of different questions. And as I say, at the moment these data are difficult, this content is difficult to use because it's handwritten. So the project's all about taking those handwritten forms and getting those into a structured, computerised format so that the family historians can still do the work with the records, but because they're computerised, they won't have to go through the handwritten books to try and find their relatives. They'll be able to use the information online, and we can do some really quite large number crunching exercises, map and analyse the data. We were required by our funder, the Economic and Social Research Council, to appoint a commercial partner to carry out this work. So with the University of Edinburgh, who co-hold the grant from the Economic and Social Research Council with us, we worked with them developing a tender, and we had, I don't know, perhaps 10, 15 applicants under the tender. We shortlisted those, and at a very early stage it was quite clear that Mobius was one of the front runners in this work. There's a lot of experience in working with manuscript material, a lot of experience in dealing with large quantities of data, and I think critically experience of dealing with content accurately. It's critical with this work that the transcription of the handwritten material is accurate so that we can identify individuals going through these life events. So we can identify a person who's born, if they got married, we want to identify the person again when they got married, and we want to identify them for a third time when they died. It's vital therefore that the surnames, the first names, the addresses are actually accurate, and we're very impressed with the level of accuracy that Mobius promised, and indeed the speed at which the work can be done as well. This work needs to be completed within 2 or 3 years, and 22 million records is an awful lot of records to do within that time. We're very confident that Mobius could complete that work as requested. What happens next is that we can plot people's life events. So we can map for the whole of Scotland. All of this data has an address with it, so an individual where they're living, we record the address. We can map for different spatial units, counties, census tracts, the average age of death, and see how that changes over time. We can look at the sorts of diseases that are killing people. We can look at various causes of death and see how those causes of death change over time. We can look, for instance, at marriages and see, did the age at which people were getting married change over time? Were people, and I suspect this is the case, in the 19th century, tending to marry people who live nearby to them because mobility was limited? You know, the roads weren't particularly good, the railway system wasn't particularly good, no air service at all. But what we expect over time into the 20th century and the later 20th century, that marriage horizons will change. So people will be marrying people further away. We can also look at the average size of families. We can look at changes in occupations. I mean, there's such a vast amount that we can do with this data. Now, most of the people involved in the project are geographers, and one of the key things we're interested in doing is mapping this data and mapping change over time. I guess one of the major challenges, there's so much data, there's so much stuff there to deal with. An enormous quantity of information. 22 million records. I'm not sure how many keystrokes, how many actual individual character strokes there are involved in this, but it's going to be millions, billions of keystrokes. So it's a real challenge. Moreover, we haven't got access to the original returns, the original handwritten books. What we've given to Mobius is microfilmed, microfiche copies of these books, and they date from the 1970s and 1980s, and they're not particularly high quality. So the handwritten text is really difficult to read. We've got a team who've been working in Belfast who have been trying to transcribe the data themselves just to see how difficult it was, and people have found it really, really complicated. So we've been really impressed with the ability of Mobius to actually read this handwritten, faded text and do so accurately. So I guess that's another part of this, that a lot of data, but we need that data to be entered really, really accurately. And we're getting an accuracy rate of over 99.5%, I think it's 99.7% at the moment, which is truly remarkable. And it's far better than I've seen anywhere else in these sorts of large-scale transcription projects. We've done work on vital registration data for Ireland, for instance, for Northern Ireland, and the accuracy rate wasn't as high for that data. I know of a lot of projects which have transcribed census data for the UK, 19th century census data, and again, the accuracy level isn't anything like as high. So we're very impressed with the accuracy level, but because it's handwritten, because the documents are old, and because they've been taken from microfilm, it's really challenging stuff. And also, I perhaps should say that because it's Scotland, there are obviously Scottish place names, Scottish surnames, and you know, I'm from the UK, that I find the names challenging. So even more challenging for someone who's from outside the UK, someone who's not from Scotland. Accuracy, I think. Maybe speed, maybe communication. Sorry, these are a lot of words, aren't they? But all good words, basically. We are really, really impressed. And I think for this particular project, it's really got to be accuracy, speed, communication.